enough songs. Chapter 4. So we're going to talk about Chapter 4 and Chapter 5. Chapter 4 is into the cell, Chapter 5 is energy, and Chapter 6 is cellular respiration. So I'm going to try to break this down in under 5 minutes. Now, if you're looking inside the cells, there are actually lots of things you're going to find out. There are microbes, there are prokaryotes, and apparently lots of actual cells came here. Now, let me explain. Cells actually weren't always like the cells we have today. In fact, they actually evolved into this. Others usually were carnivores. The original cells were carnivores, and they just ate other cells so that they can create ATP. And then there are also photosynthesizing cells who are like, I can create stuff, I don't need to eat food, but wait, I'm food! I can create food, fat. I can create, but my creation of ATP is slower than other carnivores of consumption of ATP, which is bad. Alright, okay. And so what now? Apparently lots of things actually happen with these cells, and then prokaryotes, eukaryotes, and those kinds of things started evolving. Eukaryotes happened, and then suddenly a photosynthesizing cell, like a cell ate another cell, but it apparently didn't kill it. And so that inner cell, the one that's inside another cell right now, can just relax and wait and just worry about one thing, creating ATP. It created ATP and kept creating it, while the outside, the host cell just went ahead and gave itself resources and protected the inner cell. So that happened, and then eventually this became one living being, where nowadays the inner cell is now called the mitochondria, the powerhouse of the cell. And plants are still photosynthesizing cells, except they have cell walls, which is the only reason why they are that rigid. And the only reason why we're not that rigid, like, we're smooth, people. We're smooth. I have literally shaky legs. Like, if I shake my legs, then, like, the fat part will just, like, do this little dance. And then we also have some sorts of channels and pumps. These channels and pumps also regulate how much things are inside and outside. Like, if there's just too much red here, it has to go somewhere. So it just diffuses here. And the pump, however, prevents things from going into somewhere too much, or prevents something from being somewhere too much, like too less or too much. So if there's too much here, then the pump opens and lets the thing go through, as long as there's a little chemical reaction. Like sodium, for example. Most of the time, there's more sodium on the outside than in the inside, and cells really want a balance in between them. So what they do is just, they open the cell every time three sodium atoms come in, and then every time they let three atoms come in, three sodium atoms come in, they just let 2 potassium atoms go out. Or did I get that? Okay, I got that in the reverse. Apparently, there's more sodium inside the cell than there is in the outside of the cell. So just imagine everything I just said, but in the reverse. Every 3 sodium that goes out of the pump, 2 potassium goes into the cell, which is very bad for equilibrium. So they have to keep doing that. Yikes. And so they just do a bunch of ATP. It's like the currency of the world. Then we also have metabolism, which is how we're supposed to live. And this is the only reason why entropy is not getting us and making us very boring and dead. Alright, so what's next? Apparently lots of other things are happening. Energy itself is pretty good. Energy can later be destroyed or created. Also, Gravity Falls actually says otherwise. I created a perpetual motion machine! So? It stopped. What? Stanley? Did you break it? No. Why was this there? I don't know. But hey, there's a light treasure, honey. You idiot! Smash, 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 smash. And energy itself is cannot be divided, cannot be destroyed or created. And the thing about this is that most people probably couldn't say what energy is exactly, but they'd all agree that fire itself is energetic. Well, what does energy have in common? It's something used up. It's something that lets something happen. The laws of thermodynamics actually let this all happen. Like, if something's happening, then the fuel is energy. Energy cannot be created or destroyed. It can only be transferred from one state to another. And chemical energy itself is a pretty big brain teaser too. Chemical systems are rife with kinetic and potential energy, and thanks to internal motions and electric forces. Now, when particles attract each other, anything that pulls them apart does work and raises potential energy. Like, potential energy is just energy that could happen, like a mouse trap that's set. But then the kinetic energy is when the mouse trap actually traps a mouse. And finally, last but not least, cellular respiration. Cellular respiration itself is pretty darn good, because it itself actually uses things that we don't normally do. Like, to English-speaking people of knows this, respiration means breathing. To a biologist, it means something entirely else. Like, at the cellular level, it refers to a particular way of liberating chemical energy. It's like how Like letting something in and letting something out. Like put some fuel in and getting the fuel out. Like put like a bunch of this here and water here and get this much water out. Turning this into water and adding it to this amount of water equals this. So that's pretty useful, and that's basically what respiration is. But I'm not actually going to explain it all. But however, you can just go ahead and Google this up. I'm running out of time. I'm already out of time anyway. And as I already mentioned, the mitochondria is the powerhouse of the cell. It's the only this respiration is the only reason why the mitochondria is actually still working and creating ATP. That's all I'm going to say. I'm not a specialist in this field. I'm not a biologist. I'm like a 12 and 9-month-year-old YouTuber who wants to make science videos. So yeah, that's about it. So hopefully you guys actually enjoyed this episode. Hope to see you guys soon. Until next time, shine out. Peace. Oh yeah, and always drink a lot of water. And wear a helmet.